With the power supply and the power amplifier checked, and not forgetting that we have to come back to the power amplifier because of that clipping problem and low power, as has been rightly pointed out by some of the subscribers, it was time to move on to the RF section. And this is the point where things get a little bit slow and quite difficult at times, because sometimes it's very difficult to actually check some of the components and connections on the actual RF section. And the reason for that is you've got parts of the circuit which you do not really see, like the what's inside the RF can. So you have to measure and check everything to the inputs or to the connector points of the RF cans. Okay, and the other thing that makes life a little bit more challenging is you've got a whole lot of coils everywhere, which are very difficult to measure because they're actually normally they're just a DC short. So when you put an ohmmeter, the multimeter in ohms across it, you get very low readings, and you're not sure whether you're reading the actual coil resistance or whether you're reading a short. So you sometimes have to actually desolder some of these points to measure correctly. Also, if you have a situation like this here, when you measure from that point to ground, you should get 6.8K. Depending on what positions some of the switching is in, this switch is in, you could be getting 0 volts. So you put your multimeter there and you get almost 0 ohms, rather, not volts. And then you have to switch it to make sure that you can test that resistor. So it does make it a little bit more complicated, but interesting nonetheless. And that is how far I went. There is a notable blank space right here in the middle, and that is the subject of my usual procrastination. That is the FM section, which, as you know, on this radio is really crappy. There's definitely something wrong with it. So what I decided to do was leave it alone for now. So I did everything else, literally as much as I could. I did everything else, and I will show you. The whole RF section for the AM bands is done, checked, tested, aligned, and ready to move on to the part that I'm avoiding. Let's have a look inside. This stage I actually started from the antenna inputs and literally worked myself forwards in the circuit, and it just makes it easier to ensure that you've actually checked every connection and every component, and it also makes it easier for you to ensure that your switching is in the right place when you're measuring some of those components. It's just one logical order. There's no right way or wrong way. It's just the way I do it. And this is the part that gets a little bit challenging. Coil, 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 coil. Some of them have single windings, if they're just a choke type coil, but most of them are actually transformers. They're actually 2 coils in 1 core. So you got, 2 4 connections coming out of each, and these things are practically invisible, these little wires. The most dangerous thing you can do in terms of keeping the radio working is to walk around and mess around in here without being careful what you touch, because in trying to stick a multimeter in there, you can literally just rip away that wire. And finding it for a start is a problem. It's difficult. And secondly, getting it back in place is sometimes a nightmare, because you sometimes don't know where it's supposed to go. The actual schematic, if you look at the switching, let's look for an example here. There's an example of the switch. It's very difficult to see that. This looks like 3LK, IK, is it? Very difficult to read from here. So this resolution of this schematic is not the best. So sometimes finding these points is a problem. Now what you need to do is you've got to remember how these things are laid out. And that is also shown in the other part of the schematic. they've got the layout of the push buttons with the numbering system. And here it is. So you have your buttons at the top, off, pickup, long wave, medium wave, and FM. Then you've got your matrix, which is A to L, but there's a little catch here, A, B, C, D, E, F, G, H, I, K, L. There's no J. I think there's no J in the German alphabet. I may be completely wrong, but there's no J. So again, your logic goes out the window sometimes when you're looking at this quickly. And then the rows, the columns are 1, 2, 3, 4, all the way to 10. So according to the instructions, this is how you set up the IF frequency for the AM. The IF frequency is 460 kilohertz. You put it on long wave. You couple the signal to grid 1 of the EF89, and you adjust coils 1 and 2 to the maximum. And the one thing to note here, and this happens with a lot of the German radios, is they talk about a damping of a 10 kilo ohm resistor in series with a 5 nanofarad capacitor. You're supposed to dampen the opposite coil. Now, I had to look this up on previous restorations because I didn't understand exactly what they meant. There's very little information available as to what this dampening means. Now, according to an article I read, this was a technique that all German radio technicians were taught in their course, which they all basically understood perfectly. What you do is you take a 10K resistor in series with a 5 nanofarad capacitor, and you connect those across the coil opposite to the one that you are aligning. So if you're aligning 1, you dampen 2. If you're aligning 2, you dampen 1. And what this does is it allows you to peak the 1, for example, without the effects of 2 reducing the sensitivity. Basically, it just makes it possible to align more sharply the particular coil. So, grid 1, EF89, align 1 and 2. So that's easy enough. There's EF89, you put the signal in there, and you're aligning these two this IF transformer with these two coils. To align 2, you dampen 1, so you put a resistor from that point, the resistor capacitors in series from that point to that point, align it, then you take those away and you put it between there and the next point you can find, which is actually up here. So you're dampening that coil and you align that one. Easy enough to do. And because I'm always working on these German radios, I built this up. It's just a series resistant capacitor. I've drawn it there so I don't forget what I've done. And it's wired in series over there with the two crocodile clips. Makes it easy. So that alignment gets done. Then you move the signal to the grid of the ECH81. That's a mixer tube. And you're going to align 3 and 4 for a maximum. When I measure maximum, I can either do it on the AGC voltage, but in this particular case, I measured the audio voltage by putting an AC voltmeter across the speaker and measuring the level of the AC coming out. In other words, how much that signal came out. Just to recap, this the way to do this is you feed a 460 kilohertz signal with a modulation of an audio tone, so I use about 500 hertz, modulated 30%. So I have my 460 carrier with a superimposed audio tone of 500 hertz, which I can hear, and I measure the level of that audible signal across the speaker. All well and good, until I got to this guy. I finished those two, and then I started on that one. And this guy was not giving me any effect. And I couldn't understand why. And the reason is that according to this chassis diagram, you have the two IF transformers looking at it from the back. And the AM ones are the internal ones. So you have 1 and 2 here, and immediately opposite you have 3 and 4. Okay? This is from the underside, this is from the top of the chassis. So I did 1 and 2, and that's fine. I could see the effect of the tweaking on the audio signal coming out, and I maxed that. When I went over to this one, assuming that this was the AM core, I was tweaking this guy and getting absolutely nothing. And that really left me a little bit stumped. And I forgot the main rule. If you don't see a change, you've got the wrong transformer. And that's exactly what happened. The actual 3 and 4 are on the outside, not on the inside. So instead of tweaking 3, I was tweaking D. So the FM was already off, and I was just making it worse. Which just means that whatever problem I have on FM has just been deteriorated even further by messing around with that core. Anyway, that's his life. I dampened 4 and aligned 3. I dampened 3 and aligned 4. So I got the AM, IF perfectly aligned, and the result on reception, in as much as we can call it reception on medium wave over here, was improved slightly. I wouldn't say it was greatly improved, but it was improved slightly. And we'll see that at the end, but the AM channels here are not too dramatic and too exciting. AM here means one channel, as I keep repeating, one station on medium wave in Madeira, and the rest are from the Canary Islands, which I pick up sometimes. And long wave, I can actually pick up one station from France late in the evening. That's it. Nothing too exciting. So the FM continues to be the challenge. And so what I did next was to have a look at the FM can. I decided to, instead of jumping in and start messing around with it, because I don't like messing with FM cans, I decided to have a good look at it. And I looked at it very, very carefully, and then decided to do something else in the meantime, while I thought. And then I looked at it some more. And while I was taking the faceplate off, I realized I hadn't looked at it from the back yet. So I looked at it some more. And then I realized that in order to find the problem with the FM, I was probably going to have to sleep on it for a couple of nights. So I think the logical step now would be to clean up the front, do a bit of cleanup, a full cleanup on the faceplate and the dial and the knobs and all these things that are making me distracting me from attacking the FM can, and I'll get back to that later. Right, see you again soon.